This is still test 2 review, and I'm working on problems 15, 16, and 17. And this is find the prime factorization of the numbers, and you're going to write the answers with exponents. So we're going to go to my Paint, and I'm going to do a find all the factors of 18 as well, just to show the difference. Because the prime factorization of 18, there's three ways to really do this, and one of them is called the cake method, and the other is the tree. And I'll show you the cake method. Is you begin by doing division. You list your prime numbers on top here or somewhere on your paper: 2, 3, 7, 11, 13, and you don't have to list all the way to 100 or anything like that. But these are the prime numbers, and what you're doing is you take a look at your number 18 and you say, look at the first prime number and say, does 2 go into that number? 2 goes into 18 because 18 is even, and that is according to our divisibility rules. So divisibility rules are used many times. 2 into 18 is 9. Well, and you look up here at your prime numbers, does 2 go into 9? No. Does 3 go into 9? Yes. Because you have to go to the next one. And it's called a cake method because it begins to look like a cake as you build it. So 3 into 9 is 3. So does 2 go into 3? No. Does 3 go into 3? Yes. So you say 3 into 3 is 1. And once you have the 1 on top of the cake, then you're done. And these are your prime factors right here. 3, 3, and 2. So the answer becomes, well, let's do this. 3 times 3 times 2 is your prime factorization of 18. This in exponent form, and when they were talking about that, what that means is because 3 times 3 is 3 squared, then you have 3 squared times 2, and that's putting it in exponent format. Now if we look at another method called the tree method, what that is whoops, instead of dividing, it's still you thinking through the problem using division, but you're also going to be using thinking about multiplication. But it's essentially very similar to the cake method. So you begin with your number that you want to find the prime factorization of, which is 18, and you do the same thing. Can something times 2 equal 18? Yes. So you begin with your lowest prime number and you say, yes, 2 times 9 is 18. And you have a prime number already. This is a composite number, so you have to continue to break it down. And what you do is similar. You go through your prime numbers. Does 2 times some number equal 9? No. Does 3 times some number equal 9? Yes. 3 times 3. So then you have 3 times 3. And you have all prime numbers, so you're done at this point. And well, you come up with the same answer, of course, 2 times 3 times 3. So finding all the factors, and a real quick comparison, finding all the factors of 18 is a different thing than the prime factors. Prime factors are only prime numbers, whereas all the factors are all the factors. And I did this on another video, but in case you didn't watch the other one, and you're seeing this for the first time, I want to show the comparison to finding all the factors to prime factorization. So in finding all the factors, you're looking at all the digits this time, not just prime numbers. So you say, does 1 go into 18? Is 1 a factor of 18? In other words, 1 times what number equals 18? Well, all numbers you multiply by itself. So that's 2 factors. Then I look at 2, and do I say 2 times what number is 18? 2 times 9. So far we haven't run into anything too much different. Now we look at it and say, does 3 times some number equal 18? Yes, 3 times 6. So now we're seeing something different. We have some factors that we didn't even bother to look at for this problem. So then we say to ourselves, does 4 times any number equal 18? No, because 4 times 4 is 16, 4 times 3 is 12. Does 5 go into 18? No, 5 times some number is not going to be 18 because it doesn't end in 5 or 0. Does 6 go into 18? Yes, we determined that. So what we have now is a turnaround point. We've figured out that it's 1, 2, 3, 6. The next number beyond 6 that will go into 18 or can be a factor of 18 is 9. And the next number beyond 9 will be 18. So you have all the factors at this point when you find that turnaround. So now we have to list them in order. 1, 2, 3. And then you go backwards. 6, 9, 18. So that's finding all the factors. And these numbers, these factors here, are prime and composite numbers, as well as 1, which is neither prime or composite. So that's a contrast to finding only the prime factors. Now when we look at a more complicated number like 612, let's use these methods, the cake and the tree. So we're going to look at 612, and we're going to do the cake and the tree method for 612. You have, my son is playing with his friend in the background. You start with this, and then you decide, using the cake method, you've got your prime numbers listed somewhere on your paper when you're doing this. Start with the first number, prime number, 2. Does 2 go into 612? Yes, it does, because 612 is an even number. It ends in 0, 2, 4, 6, or 8. And that's one of our divisibility rules. 2 into 6 is 3. 3 times 2 is 6. 0. Bring down the 1. Does 2 go into 1? No. 0 times 2 is 0. Bring down 1. And now you bring down the 2. And 2 into 12 is 6. Okay. So then we have to do it again. We look at the number 306. We look at our first prime number available. Does 2 go into 306? Yes, it does. Okay, so 2 into 306. Well, I can think, what's half of 306? Well, it's 153. And the little trick I kind of did is I said, what's half of 30? That's 15. What's half of 6? That's 3. So 153. Now it's a different number. It's not even. So 2 is not going to go into this next number. So we have, does 3 go into this number? Well, how do we tell? Our divisibility rule for 3 is you add the digits. 1 plus 5 plus 3 equals 9. So that tells me 3 goes into 9, so 3 then also goes into 153. So that helps me to figure out what the next move will be. And if you look at that, if you did the division, you could look at it this way. 3 into 15 goes 5 times, and then it goes into 3 once. So you automatically have 51 times 3 is 153. You can do the whole long division out. 5 times 2 is 15. That's 0 into 3, and you still come up with the same. Alright, so now you have 51 up here. Whoops, we didn't write down that 3. And cataloging and keeping track is an important part of any method that you use. So now we have 51. Now 51 can be deceiving because you could think, oh, that must be prime or something. That's just a weird number. It is, but let's go through our divisibility rules. Is it divisible by 2? No. How about 3? Well, let's add the digits. 5 plus 1. Huh. Well, it equals 6, so it's divisible by 3. So, but we don't know off the top of our head. 3 times what is 51? So let's just go over here and sort that out. 3 into 5 goes 1 time. Minus 21. Well, look at that. 17 times 3 is 51. So our answer goes here. We did 3. Now we make this. We've got this cake. It's kind of a clumsy cake. 17 is prime, so the only number that goes into 17 is in fact 17. It's a prime number in our list, which is why I can use that number. And now I have 1 at the top of the cake, so my prime numbers are 17. My prime factors, I'm sorry, are 17, 3, 3, 2, 2. So we have the prime factorization is 2 times 2 times 3 times 3 times 17, which then becomes 2 squared, because you have to put it in exponent format, times 3 squared. Bring down both the multiplication sign and the 17, and that's your final answer. 2 squared, it's a pretty funky looking squared, times 3 squared times 17, using the cake method. And using our tree method was 612. Oops. 612. And you say, you start with your 2, because we know 2 times some number, and we already sorted this out. 2 times 306 equals 12. 612. Okay, so then you have one of your prime numbers, and this is still composites. We need to break it down, but we have to go in order of our prime numbers up here. Can 2 times some number equal 306? Yes. 3 times some number will equal 306, but we don't want to skip over the 2 and go straight to the 3. That will just mess you up. You have to stay in order. So we already sorted this out. 2 times 153 is 306. Let's put these multiplication signs in there so we have another prime factor. We already know what the prime factorization is turning out to be, but I'm going to go through this. So 153, we know, we have learned, because 1 plus 5 plus 3 is 9, that 3 times 51 times 51. So it's a similar breakdown, but I know when you work on these kinds of things yourself, sometimes certain ways of doing them make more sense than other ways of doing them. And at the end here, we know that 3 times 17, we have all prime numbers, so we stop at this point, and we have our prime factorization, which is the same. 2 times 2 times 3 times 3 times 17. So that's using both of those methods.